Hello, Year 7 mathematicians. We've been looking at Pythagoras and thinking about the side lengths of right-angled triangles. And a number of you have made 3, 4, 5 triangles, and it is true that the side lengths follow this rule. 3 squared plus 4 squared equals 9 plus 16, which is 25, which is 5 squared. And that's true of those numbers, but why does that make it a right-angled triangle? We haven't proved that when the square on the hypotenuse adds up to the square on the other two sides, that means it's a right-angled triangle. I've told you that that's true, and you can see it in the textbooks, but we haven't demonstrated that it must be true. And I want to do that today. And I'd like you to copy what I've done and make your own triangles in the way that I've just in the way that I'm going to show you. So let's have a look at that, and we can take any old right-angled triangle. Here's my right-angled triangle, and I've labelled the side lengths of the triangle. Let's see if this thing will focus. Come on, focus. There we are. We'll get there. I've labelled the. Come on. Focus. Focus. Silly old thing. Come on. Irritating. I think it's because there's so much else in the way. There we are. There. I've labelled the long side of this triangle A in green, and the other two sides I've labelled C in blue and B in red. Notice that B and C are the shorter sides and that A is the longest side of my triangle. And the first thing I want to do to you is to demonstrate that this must be a right-angled triangle, that there's a right angle in here between these two sides. We need to know that it's a right angle if we're going to prove that Pythagoras Theorem applies to right-angled triangles, not some other sort of triangle. That might be a right angle, or it might just be 89 degrees or 91 degrees or something. How do we know it's exactly a right angle? And the reason we know it's exactly a right angle is exactly 1/4 of a full turn. Now I've got 4 identical triangles here, which I've made, and here are the 4 triangles. Look, there's the first one in its position. If I turn it 1/4 of a turn, it goes to the second position. Another 1/4 of a turn, and it goes to the third position. Another 1/4 of a turn, it goes to the fourth position, and then back to where it started. So the angle in here, and the angle in there, and the angle in there, and the angle in there, they're all the same, and they must add up to 360 degrees, one complete turn, so we know that that's a right angle. I'm going to draw that right angle in here, like that. There's the right angle. There's the right angle in that triangle. There's the right angle in this triangle. There's the right angle in that triangle. Now I've made a mess of everything, but let's put it all back together again. Now I have an object which is right angles all the way round. You know the rule that the angles on a triangle add up to 180 degrees. So if that's a right angle, then this angle plus this angle must add up to 180. But since this angle and this angle here are the same, these two angles must add up to 180 because the triangles are all the same. Sorry, these two angles must add up to 90. I'm sorry, I made a mistake. If this angle is 90 and the angles in the triangle add up to 180, these two must add up to 90, not 180 as I said before. And that means that these two angles here must add up to 90, and that means that this is a 90-degree corner. And this whole thing here is also a 90-degree corner, and we've got a 90-degree corner up here and a 90-degree corner up there. Well, that means that this object is a square. And the length of this square is the green label A. There's the A, the length of the square, and the width of the square is the same as its length. It's also A, and A. 90 degrees, this is a square. Well, what's the area of this big square? Well, the area of this big square, I've jumped it up. The area of this big square is A squared. And I'm going to reorganize the square. Let's put it back together again. I bumped it into a bit of a mess. I'm going to reorganize the square in this way. I'm going to take these two and put them over here like that. Let's just make sure that you've got that in the view. Those two there like that. This bit left over in the middle I'll deal with in a minute. I take these two and join them A side to A side and put them there like that. And then I go back to my little bit of square left behind in the middle, and that fits in here like this. Now what have we got? Let's take a pencil, for example, and put that there. Now the total area of all these pieces of paper we know is equal to A squared. But now let's have a look and see what we've got. We've got a square here as far as the pencil, on this side of the pencil, on the left hand side of the pencil. Let's just move the camera so that you can see all that properly. We've got a square here which is B times B, so that's B squared. Let's put that in on my formula, equals B squared. Notice A squared equals B squared plus the square on this side of the pencil, and you can see, look, the length of this square is C from there to there. It's also C from there to there. So this thing is a square of side length C. So it has an area of C squared. Well, the area of all these pieces of paper is the same as it was before. It started out as A squared, and now it's B squared over here plus C squared over there. And the triangles are right-angled triangles. We proved that before. So this proves that Pythagoras' theorem is correct for all triangles. It doesn't matter what the values of A and B and C are. Now you've seen me do this. You've seen me operate the video. My challenge to you now is that you make for yourselves a square out of 4 triangles like this. The triangles have to be identical, so you have to copy your triangles. The triangles have to be right angles in the corners so that they fit together properly. And then you have to fit them together to make a big square like this. Let me see if I can get this organized. There we are, like that. And like that, and like that. Is that still in the viewfinder? Yes, it is. Let's turn this square around so it's straight on. Then you need to make a little square that fits in the middle there like that, so that we have an area of paper equal to A squared. And then I want you to look at the video again and again if you need to, and find out how you have to move these pieces of paper around to get the shape that I showed you before, which is B squared plus C squared. And since the area of the paper hasn't changed, I haven't thrown any of the bits of paper away or changed the size and shape of any of the pieces, I've just reorganized them into a different shape, then that means that A squared equals B squared plus C squared. So I'm going to finish the video by showing you how to reorganize the pieces of paper. And what I'd like you to do is you could make your own videos, or you could show your parents how this works, or anybody else, or a friend or something like that, and make sure that you know how to do it. Okay, so I'm going to finish by reorganizing the pieces of paper into the appropriate shape so that you can see how it fits together. So try this for yourselves, and I look forward to seeing your videos and things. I will remind you that I want to see your projects on Pythagoras. You could incorporate the video if you like. I want to see your projects on Pythagoras, whether or not they're finished. I want to see some work from everybody today, or emails will go out. Right, let's do this, and you can follow and see what's going on. I take the little bit of paper, the square in the middle, I take that out and put it off to one side. I'll put it where you can see it so you know I'm not cheating. And then we reorganize the pieces of paper like this. Those two go there like that. these two go here like that. So we've got two rectangles. Then we take the little square, it fits up here like that. And now this shape, this L shape, is actually made of two squares. We can separate it on either side. There's the pencil. The stuff on the left side of the pencil is b times b. It's a square, b squared. And the stuff on the right hand side of the pencil is c times c, c squared. Just as an aside, as an extra thing, what's the side length of the little square that I put in there? Because that little square needs to be just the right size in order to complete this medium-sized square and this slightly smaller medium-sized square. Remember that the big square is a times a, the thing that we started with, which is everything. So I'd like you to be able to do that. I'd like you to make your own squares and colour them in. You'll see I've used green for A and red for B and blue for C. And see if you can repeat the experiment and show it to other people. And that will confirm to you that Pythagoras' theorem is completely correct. Now that's not the only proof, and you can go and look on the internet and find other proofs of Pythagoras' theorem. I look forward to hearing from you all. Okay, bye-bye.